Hello everyone, welcome to Computer Science and IT Gate Coaching. Don't forget to subscribe my channel and press the bell icon to get the instant notification of my free lecture. Now see, Gate 2011 question. So it is saying that definition of a language A with alphabet A is given. So sigma they have given, only A, sigma is your A, and definition of a language they have given. So the definition of language saying A equal to 8 to the power nk such that k is greater than 0. So k is greater than 0, it is a variable, and n is a positive integer constant. N is a constant, its value is not going to change. N is a positive integer constant. K's value is going to change, k is a variable. So they are asking what is the minimum number of states needed in a DFF to recognize it. Now they are asking what is going to be the minimum number of states required in the minimal DFF, because they are saying that in minimum number of states in the DFF means minimal deterministic finite automata. So option they have given for k plus 1, n plus 1, 2 to the power n plus 1 to the k plus 1. So we will see one by one. So let us assume n equal to 1. If I will assume n equal to 1, then k can be any values like 1, then 2, then 3, then 4, then 5, because it is saying that k is greater than 0. Okay. Now if n is equal to 1, then language is going to contain a 1 1, first 1 n into k, 1 into 1, then 1 into k, 1 into 2, a2, then 1 into 3, a3, then 1 into 4, a4, then 1 into 5, a5, similarly a6, a7, a8, like this. So this language is containing a2, a3, a4 when n is your 1. So n is always going to be a constant. Here I have taken n equal to 1. Someone can take n equal to 2, 3, like this. But whatever you are taking n, it is going to be constant, and you are going to vary k. Now construct a minimal DFF for this. So it will be initial state is not going to be final state. Why? Because epsilon not belongs to this language. Now you need to accept a. So by only getting a, you need to go to the final state. Now again if you are getting a, accept it, again getting a, accept it. So after that any number of a you are getting, you need to accept that. So you need to be in a final state after getting a. Now see, when n is your 1, you require 2 states. See, when n is your 1, you require 2 states in your minimal DFA. Now try to eliminate the option. See, k is going to vary. It means option is never going to be your correct option. Why? Because k is going to vary. It will not never depends on the value of k. So this option is incorrect. Even this option is incorrect, because it is saying that based on k it is going to vary. Now try to see B and C. So when n is your 1, you are getting 2 states. See, 1 plus 1, 2. Yeah, correct. This is correct. It is giving 2. Now if we use this option, it is saying 2 to the power n plus 1. So your n is your 1 plus 1, 2 to the power 2, you are getting 4 states. So this formula is saying that you will get 4 states, but this is saying that you will get 2 states. So when n is your 1, you are requiring minimal DFA 2 states. So this option is correct. This is incorrect. You can even try for n equal to 2, n equal to 3, and you keep on varying k. Okay, so show you when n is 2, how it will look like. So I am taking n equal to 2. Then k is going to vary from 1, 2, 3, 4, 5, 6, like this. So the language is going to contain 8 per nk. So a 2 1 2, then 2 2 4, then 2 3 6, then 2 4 8. See, then 2 5 10, then 2 12. So if you see, it is going to contain the multiple of the first. When it is 1, then 2 3 4. When it is 2, then 4 6 8. So when it is 3, then 3 6 9. So it is the multiple of n. It is the multiple of n. N into 1. See how k is growing. N into 1, n into 2, then n into 3, then n into 4, like this. K is going to vary from 1, okay, 1 2 3, like this. So it is going to contain multiple of n. This language is containing multiple of n. Okay, what that means, number of a is going to contain. So how to construct a minimal DFA for this? Initial state. Now by getting 2a, it will accept it. 2a accepted. Now again if we'll get 2a, then accept it. Now after, if this state will get a, it should not go again create new state, no need to create. You can come here and then again see 0 number of a 1, then 2, again getting a 3, again getting a 4, again getting 5, again 6, like this. Okay, so here I need to create a loop of 2, 2, 3, 4, 5, then 6. See how many states we require here. When n is 2, then you require 3 states, so n plus 1. Okay, so if you take any value of n, always it is going to give you n plus